So if you're a Laravel developer or work with one or have considered becoming one, you know that maybe the best reason to use Laravel is productivity. And what I mean when I say productivity is that most of the problems that you might not want to spend time solving have already been solved and tested for you and provided for you for free. It takes about 10 minutes to spin up a default Laravel application with authorization and multi-tenancy, and then have a coffee, all within the, So there's a reference book about design patterns written by the Gang of Four, and the language that I'm going to talk about, Laravel, comes from that. I'd like to talk about what Laravel developers can gain by knowing about design patterns and what people who are familiar with design patterns might see in the Laravel core application framework. One thing expert designers know is not to solve every problem from first principles. When you build with Laravel and its ecosystem, the first and third party packages, you're learning from other people's mistakes and benefiting from the opinions they hold as experts. So that means you're probably going to ship. Laravel makes it incredibly easy to reuse successful designs and architectures. I think we can agree on that. Using Laravel helps you use proven techniques that make implementing functionality and shipping features more accessible to developers of new systems and new developers. It helps you choose design alternatives that are reusable and avoid alternatives that compromise reusability or add to complexity and coupling. And the built-in functionality improves documentation and maintenance of existing systems. And the way that it does that is through the registration service container, the service providers and packages that we rely on through the community and that you can build yourself, and the inherently decoupled design that you see throughout the core framework. This talk is not to tell you that Laravel developers need to know about design patterns to use Laravel or ship applications, because you don't. Moreover, learning them in depth is outside the scope and the time limit for this talk. Rather, it's an invitation to programmers who are already familiar with design patterns to see how Laravel uses those to solve a problem, which I think is interesting even if you never use Laravel new. And a reiteration to Laravel developers who are maybe more interested in shipping than the theory of design patterns, to consider that they're already using a very thoughtfully designed, sturdy, and elegantly implemented framework. Whether we choose to look at it or not, it still works. So let's talk about some jargon that I'm going to use. I made up these definitions. They're how I'm going to use the terms throughout the talk. And I'm kind of using terms that are in between design pattern terms and Laravel terms. So they're mine. An interface is a definition data type that serves as an agreement. When you have the data type that's an interface, you say what methods or attributes are going to be present in a class. You don't implement them. They're almost useless unless they're implemented later. A contract is a group of interfaces, usually combined through inheritance. That's a Laravel-specific idea of a contract. I can't really speak to it outside of Laravel, but when you see contract in a file path in Laravel, you're looking for multiple interfaces. The purpose of a system is what it does. This is an idea I really like. Your intentions when you build a thing don't really matter to your users or the person who's paying you to build their software. Neither does your tech stack or your philosophical ideas or your fancy architecture. Observing and analyzing the actual behavior of systems is more important than focus on planned or theoretical functionality. So when I talk about design patterns, I'm not necessarily going to be talking about canonical, classical implementation of a design pattern. I'm going to be talking about what actually happens from the perspective of a user or the perspective of other packages interacting with your application, how they're getting things done in a request, basically. So, purpose of a system is what it does. It's an opinionated talk. So implementation, what's implementation? Process or phase of development where making the software take shape. You're not designing it, you're not testing it, you're implementing it. Well, I guess testing is kind of iffy, but the pattern as it actually exists in your software, the purpose of the system, what the system is actually going to do. Here are some activities that count as implementation. Writing out functions or methods, designing and constructing classes and objects, like actually writing them down, APIs, actually integrating them, using the structures, testing and debugging, optimization, and refactoring. That's what I mean when I say implementation, because it can be kind of murky. It's a wide definition, but I use that a lot. So, an abstract implementation, an interface or a contract, abstract base class, the vaguest idea of a class that you have, but you haven't coded it. A concrete implementation, real actual methods and attributes that you can store data in, which can and do exist as instances of classes in code. So a common thing that you're going to see in these patterns is taking an interface where the attributes or the closures on the interface are useless because they're basically null, and then implementing them concretely by actually, I said it again, I spelled it phonetically. Defining those closures as the specific instance of your class is going to use them. So we see that a lot. And then a classical implementation, sometimes I accidentally say canonical implementation, is code that is exactly like it says in the design patterns book. We're not going to be talking about that a lot, but we will be talking about comparisons between a classical implementation and what I'm going to be talking about that I see in Laravel. There are a couple stretches, but I am making some arguments here. So that was the introduction. This is my talk. Much ado about naming. Design patterns Laravel developers might want to be aware of, but you're already using them, so you don't have to be. We'll start with a singleton. So the core parts of a singleton is it's a concrete implementation that instantiates an interface of a class. So that idea of you take an abstract implementation, you have one of it, it actually works in your code, that's a singleton, and there's some method of ensuring that there's only one of this class in an application runtime. So you'll see index PHP here. I'm going to skip the maintenance part because that's a little bit above my pay grade. Vendor auto load, we're going to get all of the packages that Composer is going to manage for you, all the dependencies. And then we're going to require once, which you'll see once. We're only going to use this file that we're referring to, this Bootstrap app, one time, so it is going to be a singleton. And what we're going to return is the application class, one instance of that class. And then we can send that through the chain method handle request to start off the request life cycle. So in the application class, we're seeing that we're taking the foundation class application. So that's a little bit redundant at this point, but I like rainbow, so we're kind of layering as we go a little bit deeper. Then when we get to the application, we see that we are extending container and we're implementing application contract. And just to really go over what I mean by those things, we're taking some interfaces and we're going to make something that we can actually interact with. And you'll notice that it starts with extends container because the very core part of an application instance is the service container. So this is probably pretty small to read right now, but it's going to extend the container interface. These things are named very well and very clearly, which is a really wonderful attribute of an open source project, because if you're reading somebody else's code and you're like, oh, it's a container and it extends container interface, you have a solid idea of what's going on, which is a good reason to know the language of design patterns. So we see in this container interface, we have this function bind. Right now we're passing concrete, it's just null. That's the default value. We have an abstract that's going to be a string, not much to do there. But since our application is going to implement this interface, we now have it in our application. And now we have the application object that we are going to return. We have one of those, one service container, one application, and we can start off this request cycle because we required it once. So if I was going to do a diagram that I didn't steal from a textbook of a singleton, it would look like this. So we have the instance, which is going to return the unique instance. We saw that on application because we got the application instantiated. Singleton operation, So the singleton operation that we're overwriting in the concrete instantiation is going to be bind. Get singleton data can be multiple functions, really, depending on how you look at it. There's a lot of different ways to guess what that one is. Then we have the static unique interface. We saw that the container and the application inherits something and overrides it, and implements additional Laravel specific functionality, but we also saw that the container has multiple interfaces that are being implemented. I would argue that the container is the most important one. I think that that's probably a pretty popular opinion. And then the singleton data is going to be all of the configuration that we just did inside of the application instance that creates the environment where we can send our request. So we create the universe to send a request, basically. So if you need something in your Laravel application, you need a service to do the thing. Where's the service? In the container. Where's the container? It is the fundamental part of the application. So there's a lot of, many service providers are bound with a special method of bind called singleton, which is mostly just a wrapper around bind that ensures that there's only one instance of the class. So you've got singletons inside your singleton, so you can singleton what you singleton. Every service is a singleton. They all work by fulfilling a series of promises of things that you do or store in your app. And they exist in the service container as a concrete instance. Many of those services are not just singletons, they're also factories. So the next thing we're going to look at is the factory design pattern. What's a factory? It is one of a few design patterns that exist to create instances of a group of subclasses. So you have a family of products. The subclasses instances vary, but they have a similar structure, so you don't want to go like too wild with things. And it uses an interface or a contract to ensure variant products have all of the required attributes. So if we want to make an instance of a service provider and then have that create drivers or services that we're going to interact with directly, generally we use a factory, and they'll vary based on the specific one that you're using at the time, the configuration, the point in the request lifecycle, all those kind of things, but generally have the same structure of the service provider that you asked for. So here we have the session service provider. That's going to be the abstract creator. That's what the design pattern book would call it. It promises you a driver for a Laravel session. And it's a pretty general, not very useful by itself, register method on the session service provider class. So we're going to first register a manager, which is going to be a concrete implementation of a specific type of driver from a session. So it depends on what session you're asking for. And then we're going to register the driver. If you're thinking, wow, that implies that each specific type of session has a specific type of driver, then you're right. And that is where we see that agreement come into fruition. And then all the sessions are bound to the service container using the singleton method that we just saw, using the name of the session class as the first parameter, and then a callback instantiating the service as the second parameter. So Laravel uses the structure that's specified in the session service provider in combination with behavior in session manager to allow concrete instances of session to be implemented in actual driver instances like file session handler. You got the handler, which comes into the we have the handler, which has a construct function on the driver, and then once we get the driver, we can register that to the service provider. We have a similar thing in database, but when we look at the construct, we see different parameters because we need different things from a database session. We might need multiple database sessions. And so this is, if I were going to draw a diagram of the factory pattern that I, create myself, it would have a product, a concrete product, a creator, and a concrete creator. So the product in this case would be the driver that we're using for the session or the specific session object, and it would be inherited by the concrete product, which we interact with directly. And then the creator and the concrete creator are going to override the instances provided for us by the contracts and the service provider. So you might notice that the file paths of these classes, we're seeing a lot of hints to the behavior of the actual classes. It's not a really subtle hint that the factory pattern is implemented in factories. A benefit of design patterns is that the terms abstract and creator and concrete creator are specific to the factory pattern, and you can recognize them in other services too. The connection factory class is the abstract creator for Postgres connector, and that's going to create a connection to the database, which you might use in a facade if you reference DB. In Laravel, facades are static proxies to classes in the service provider, which makes them different than how you would use a facade in other terms. But they're also a design pattern, and a classic implementation of a facade pattern is not the same as what you see in Laravel. So that brings us to the facade. This is a diagram of a facade. The example here is basically a lot of complexity that you can't see, and then the facade is the access point. You can call one method on the facade. It provides a simplified interface for a larger system of code, hides complexity from the objects that interact with it, so it limits complexity that teams of developers can actually accidentally interact with, and it doesn't affect any of the hidden parts of the system. So here's another example. It would be a compiler. You don't really want to touch most of the compiler if you're working with it, but it does have a facade that uses compile. That's helpful. So a facade in Laravel allows you to access a service provider class binding from anywhere, the specific instance that's registered in your service provider in that application environment. You can write custom facades, even if you don't have a if you don't have a use case for one of the many facades that Laravel provides. Makes a sweet vanity plate. It's a good name. You can always talk to people who use other frameworks and argue about whether you personally should be allowed to access the service container. But the more you know about the facades, the more you can have that conversation, so it's good. This is a list of all of the facades that are just built into Laravel that you could use without having to do anything about it with a real-time facade. But you can turn any class that's registered in the service container into a facade anytime, which is very powerful. So, recap and overview. At this point, you probably noticed that all the things I'm describing are examples of in the bootstrapping stage of the Laravel request cycle. More information available on the Laravel docs. We have the service container, a singleton, which is instantiated at the beginning of the request. Services bound to it are factories. They create the parts of the service that you interact with. And that all of this is done when a Laravel app is booted up and a request is about to be sent. These services are statically accessible through facades, which hide their complexity. And they're modifiers of and modified by the request cycle in the form of the request object, which ultimately gives you your response object, which is where we get to have the most fun. So the problem that we're talking about that Laravel is solving is sending a request to the server and handling the response, the classic question of web application development since the dawn of time, which, as we all know, is January 1st, 1970. So here's an overview of the parts of the request cycle and some design patterns we can apply to every step. Once the service container is built, we moved on to the HTTP and console kernels. So we can consider inversion of control or dependency injection. And then we'll talk about the builder pattern a little bit, which is kind of a stretch, but I really like it. Then in routing, we'll talk about the iterator and the strategy. And to finish up, we'll talk about the command pattern or the action pattern and see if I'm brave enough to try the observer. So the next ones are going to go a little bit faster. Inversion of control is a really important concept in PHP, and it's a tricky one to research because it's not actually in the Gang of Four design patterns book. but design patterns do use small talk, which is kind of similar to Java, and there's not a lot of good reasons why you would use inversion of control or dependency injections if you were writing Java code or small talk. So it makes sense that it's not in there. I could make a really strong argument, I believe, that the service container is a factory. And because the pattern is more of a linguistic template than it is a concrete thing, I wouldn't really be lying, but the honest answer is that the service container is much more an example of inversion of control than it is an example of factories. So there's 4 varieties of inversion of control, and they're mostly discussed in a blog post by Martin Fowler. The specifics are really outside the specifics of the scope of this talk, but if you want to look it up, that's a great place to start. Laravel uses kind of a combination of 3 and arguably all 4, but I think the most important thing to focus on is dependency injection. So what we do in the service container is bind services and singletons, which defines how the container should be, defines how the container should construct an instance of those services. It creates services if they need. It's sometimes called auto-resolving or resolving, and services can be created correctly when they're needed for a particular request or automatically resolved for dependencies, which simplifies a lot of things and makes code just work. It's very beautiful, especially coming from other languages and ecosystems. Internally creating instances of the required dependencies for a given class and providing or injecting them when creating the class is the core of the service container. So binds services and singletons, resolves and auto-resolves dependencies, creates and injects dependencies, and here's an example. You have a controller with a type-hinted dependency. So this is just a thing I made up. It's user controller, and it has a constructor, and we're trying to find logger service. So constructors are often used to import dependencies through dependency injection. So a constructor method in PHP is automatically called on every object that's created. So if you put the dependency right in the constructor, it's going to get called. And it makes it a good place to configure or initialize any object. So part of the benefit of knowing design patterns is that sometimes we see indications in code that help us read it faster or help us communicate those ideas to other developers faster. So when we see construct and a class being passed to construct, it indicates that we're using dependency injection, and the service is resolved when the constructor method is called. So another pattern that I think is pretty relevant here is builder. It's a solution when we want to build a complex object using the same construction project to build different representations. So it helps us reuse functions in the same project for different representations of that object. We produce complex objects, so generally when we're using a builder pattern, we're not doing like 2 functions, we're chaining in a lot of things. And the representation is determined by a participant that the gang of 4 would call a director, which determines the build steps that lead us to the complex object. So we saw in index previously that we're creating a request. And this request call in the second line is going to return a request object, which has to be constructed. One of the unique things about every request is the middleware that's applied to it. And so when we chain the function with middleware in our application, we're going to get a middleware stack that is specific to the request we're making and the application that we'll be making. So this is how I would draw the gang of 4 terms for the builder. And you might notice that the small talk code under constructor is a iterator, but we've got a director that's in charge of the construction, a builder that builds each part, and then the concrete builders have different implementations of the algorithms, build part, get result, or I guess we would say closure because we do PHP here, and then the product is what's eventually going to be returned. So a useful way of looking at middleware might be that the kernel handles middleware. So middleware is defined in the kernel in this protected middleware array, and also in the middleware groups section, which is a little bit of a different way to define how middleware would go through for varying requests. So we're already seeing that within one application definition, in a different request cycle, we might have a very different middleware stack. We can also choose what order middleware should be added to the request object. And for every middleware, there's going to be a method or closure within that middleware that determines whether or not the request should go on to the next middleware, how the application should interact with it, or if the whole thing should go in a different direction. So it's a very complex object, and I would argue that the pipe that we see in send request through router acts like a builder to build a request object through the iteration through a pipeline, but still an ordering of middleware classes. So we're in the kernel here. And in send request through router, we'll see this new pipeline, which takes these chain methods send, through, and then. So we're going to send the request through the middleware and then a destination. What we eventually want at the end of the building a request will be a response. And in order to get that, we need to have the router involved. So I would say that the pipeline is like the abstract builder, and then the concrete builder could be any middleware, which are all registered to a service container and available if they're needed. They're basically loaded lazily. And then through that, we get the request object, which we can send to the router. So again, in this way of looking at this pattern, it's not really a classical implementation of it, but we are reusing functions for different object representations. We do have a constructor pattern that we're going to use to produce something potentially very complex. And we have a representation determined by the director, which, if we look at it as the kernel, also stores the middleware and contains a lot of different functions to operate on it. Sometimes I think that complicated ideas in application architecture are more useful when you have a couple different ways that you can look at them through. And I really like this one for middleware, although a pipeline is the more accurate pattern, admittedly. So service providers. I don't have anything to say about this right now. We talked about it kind of a lot. They're very important. If you want a Laravel app that does anything, you have to have service providers. Moving on. Routing. So we're going to talk about the iterator. So I used to think that iterators were basically just lists. And you had like the next item in the list. It was only after I started looking to design patterns that I realized that an iterator is a lot like a cursor. It's also called a cursor pattern. And what we're thinking about when we look into an iterator pattern is where the pointer is at any given time and where the head is. So as we go through this pattern, we start going through the iterator and we just check if the current value is null. If it's not null, we get the value. Then the next value should have a shift of the cursor. Then we return the cursor, set it to head, return a reference to the list, and then start this part again where we say, is the current value null? And if it's not, we go through again and again until we get a null. And then we have some kind of way of iterating through the array end. In Python, it's always like raising an exception, but PHP is a little bit different, and I don't read C that well, so it's kind of hard to look at what's happening right here. But so with an iterator, we're going to access the elements of an aggregate object. It can be different kinds of aggregate object. It doesn't have to be just a list, even though that's what I used to think that it was. We avoid exposing the internal structure or bloating the list. So it has some benefits for reducing complexity by not allowing other parts of an application to interact with parts of the list that it shouldn't at a given time. And we can traverse the list in different ways for different purposes because we're defining and implementing an interface that is a contract of how we want to interact with this collection. This object. A collection is a very useful type of iterator. Eloquent collections and collections in Laravel have lots of different methods and therefore lots of different agreements with which you can interact with a iterator. So this is kind of the gang of four terms again. We have an aggregate and a concrete aggregate, which is the inherited implementation of that aggregate. And then we have an iterator and a concrete iterator. So if we were looking back at this, we might say that these general purpose functions would make sense with that flowchart. Next, first is done current item. It's kind of a good way to think about things. The collection in Laravel implements an iterator aggregate interface from PHP. So they have like different names. Reset is going to get you the first item. Current is going to get you the head. End will get you the last one. And then key gives you information about the index, which is very useful. That PHP standard gives us more abilities to manipulate and access indexes off the bat than arrays in other languages. So that's very cool. And then what we're going to inherit here is the abstract route collection. So we just have like a get iterator function. What we're looking at here is the route collection, which is a special type of collection on get routes. And one of the things that it has is instead of just returning a new concrete iterator, we're returning the array values result for all of the routes in our Laravel application. So it's a useful way to see what routes are registered and interact with them. Then the routes array has the same like built-in functions from the PHP interface, and we will interact with the route collection differently than other collections and differently than with arrays in general. Then we have the strategy pattern. The strategy is going to maintain a reference to a strategy object in a context. So in this case, we're going to be talking about a controller. The strategy object is going to inherit an interface used to declare an interface algorithm to all supported algorithms. So every object that we have a strategy pattern on means we have a closure or a method that has the same name, and it's going to be implemented differently on every different subclass or different type of class that inherits that interface. On a concrete strategy implements a specific behavior. So this is a little bit vague looking, but we whatever the context is for a specific strategy, we're going to have a strategy that we can inherit, and then the different versions of the strategy and the different instances of the versions of the strategy are going to be implemented a little bit differently. And we've seen several good examples of this already, so I don't even need to show code. So the middleware. With middleware is kind of the context. Really the application is the context. Middleware has a function called handle. All of your specific types of middleware have a function called handle, but you know that when you call handle on verify CRSF token, it's going to have different behavior than render torchlight. But if you are referencing the object not directly by its name, but as a parameter or a object in a list, you can know that you can call any middleware by that handle function, which supports my metaphorical argument that the pipeline is acting a lot like a builder, because all we have to do is call a handle on any of those middleware and know that those will be implemented in a consistent way throughout the middleware stack. A classic example from the Gang of Four book is the relationship between a controller and a view. So you'll have different controllers. Within a controller, you'll have different closures, which will return different views. But the views that you actually define in a separate part of the application, the blade templates or JavaScript view, whatever you want to use, is going to be rendered differently by each controller. And you can use completely decoupled views in multiple controllers or different controllers. You can limit the behavior you're willing to accept from a user just by passing a view into a particular controller. So that's a way to decouple it using a strategy pattern. In Session Manager, when we want to bind a session to the service container, we're always calling construct through a more convoluted method than a developer actually trying to call construct. But it goes through build session in a similar way and is bound to the service container ultimately as a variant of the session, even though the method that we're calling is the same. So that's strategy. And then finishing up. Yes. So I asked Nuno what his favorite design pattern was for a while, and I got an amazing thread on X and pink area out of it. It was beautiful to watch. He said that it was the action pattern, which confused me for a minute because in the Gang of Four it's called the command pattern, but it's really the same thing. Another example of why the terms don't matter too much. It allows you to encapsulate a request as an object, which contains an execute operation. You can parameterize clients with requests. So you can pass a request into the client and operate it on that way, which is kind of if you look at it, it's also kind of a different way of inversion of control because you don't expect the client to necessarily work with some request that it contains. Rather, the request can be separate and passed to the client. It supports undoable operations, and it's great for logging. So this was the picture that he posted in this thread with the answer. So the client, in this case, is the entire structure that we're talking about. It's the app context as we observe in the request cycle with a form request coming into it. And the invoker, the requester, is the client's browser. So we fill out a form, the server receives the form, and then it initiates a request and therefore the request cycle. The form request is the command, and it becomes the commander action object, which contains the logic for validation and authorization. So it will have multiple actions on it. And then when we call handle, we are calling a specific action on that form request. The controller is the request within the context of this controller closure, which evaluates the form validation and interacts with the model and then returns the appropriate response. And it's very helpful if you want to reuse logic, because once you have a class that has a handle method on it, you can use it in the HTTP kernel, the console kernel, which we didn't really talk that much about, but you can make similar behavior on similar models, anything that has the same parameters. It's kind of like magic. So in that thread, Daniel Colborn said, what if the code that was identical, but it was event fire instead of action handle? Verb spelled. Yeah. I think that in many cases you can simply change what your class extends from action to verb/event and it would keep working. Both have a handle method, which I thought was awesome. So that brings us to the last pattern I will discuss today, which is observer. So the observer pattern has a subject, which maintains a lot of objects which depend on it. It notifies objects of changes in its state, and the state changes can be represented as events. I just put that third one in there. That's not part of the design pattern. It's just a thing that I like. So, but it's true though. So the subject, in this case, is the eloquent model that's going to be observed. The concrete subject is an instance of the eloquent model that's going to be observed. The observer is going to define an interface for the objects that should be notified of changes in a subject. Don't really see that in Laravel core. It might be because I couldn't find it, but I don't think that a Laravel observer inherits anything. I think in Laravel, an observer is more a place where you can put a lot of events and store all the events in one place. So that's kind of like a variant on the design pattern, but it seems to work pretty well. And then when I followed up with Daniel about it, he sent me this and said that he thinks that it's pretty cool that you can actually have, well, verbs is a library for Laravel where you can interact with events without having to know all kinds of vocabulary that are related to how one would normally do event sourcing. And so this code is extending an event and showing here that in the handle function on that event, the observer is actually stored in the events. It's kind of injected in a way that prevents unexpected behavior or untraceable unforeseen consequences that sometimes happens as a result of this pattern. So verbs is cool. I didn't know you were going to be here. I do think it's cool. So the conclusion. This whole system is really cohesive. I did a couple of streams, like 5 people showed up, but a couple people asked me during and afterwards what I like about Laravel and why I would choose Laravel. And what I do find so beautiful about Laravel is not so much the appearance of the code or its clean qualities. When I say beautiful, I mean the choice of design patterns it uses, the expertise that's given to people, and demonstrated in the way that it solves the web's classic problem: how do we handle a request and return a response? The skill and taste that's given away is unparalleled, in my opinion, in other frameworks and ecosystems. And not just because these solutions adhere to a terminology of patterns, but because the code is implemented in ways that have been proven to work. That code is reusable. The implementations are not always canonical or classical, but they are thoughtfully designed, and they work well together in a system. So when the creator of Laravel says that the most important part of Laravel is the community, it's important to realize that the way Laravel was designed from the beginning makes it easy for a community to interact with it because of the naming conventions, because of how easy it is to read the code and how extensible it is. I've always been a big fan of semantics and of how they relate to syntax. By semantics, I mean meaning. And linguistics, psychology, neuroscience, and philosophy can say much better than I can why a word evokes a specific meaning. The meaning of objects in a context of an object-oriented programming language is more complicated, but in some ways less difficult to explain than the syntax that we have, the semantics that we have in programming. For one thing, the objects that we have to interact with as programmers can be referred to by different names and retain identical structures, or they could retain the same name while their structure is completely altered, or it could not be recognized without the context of that name, or it could just be anonymous, but it would all be the same thing. It's very confusing. As developers using object-oriented programming, we design and build systems in which objects with similar structures undergo transformations via vastly different processes based on conditional branching and based on their internal structure or on completely external circumstances. We consider objects whose structure and meaning are dependent on other objects and the behavior of a user we are ultimately forced to imagine. This expansion on what I mean by semantics has already crossed the line into syntax and the grammatical rules which connect language. The grammatical and algebraic rules that govern the behavior of this code ultimately creates the behavior we've envisioned and depends on the nature of these objects. The processes that we use to modify them are ultimately born of grammatical rules. But this is simpler than regular language as well, because every object in programming language has a clear definition if you look hard enough. We have the luxury of a knowable system, and in particular in Laravel, we can source dive. Basically what I'm saying is a little bit of overthinking on top of the opening sentences of design patterns, the canonical reference for my topic of the talk today. Going back to some of the things that I said about Laravel at the beginning of the talk. Well, design patterns make it incredibly easy to reuse successful design architectures. Expressing proven techniques as design patterns make them more accessible to developers of new systems. Design patterns help you choose design alternatives that are reusable and avoid alternatives that compromise reusability. And design patterns can even improve the documentation and maintenance of existing systems by furnishing explicit specification of class and objects interactions in their underlying intent. Put simply, design patterns help a designer get a design right faster. And when I read this in the first chapter of design patterns, I thought, all of that applies so directly to Laravel. My opinion is this: learn design patterns or don't. The right tool architecture and implementation is always dependent on what you're building. Design patterns are just one way to talk about design we can agree solves problems. But I hope whatever you're building, you're talking about it in whatever terms are most comfortable for you. Because when I started to try to talk about it, it changed my life for the better. I'm sorry, I'm being so weird right now. So I'll leave you with a final blessing. Laravel forever. Thank you.